our next lesson is all about finding possible values of a random variable. So this is our lesson 3. So our objectives for this lesson are expected to find the values of random variable and illustrate the steps in finding possible values of a random variable. So let's have a recap. So a set of possible values from a random experiment is what we call a random variable. We use a blank letter like X, Y, or Z to avoid confusion with the variables used in algebra. Do you think is the answer? So we use capital letters. So let's have an example. Rolling a die. So you have there the die. The random variable X is the number on the top face of a die when it is rolled once. So the possible values for X will be 1, 2, 3, 4, 5, and 6. So you already know that a die has 6 spots. So it has 1 spot, 2 spot, 3, 4, 5, and 6. And the random variable here is the number on the top face of a die when it is rolled once. So when you roll a die, it's either when you roll a die, it will appear 1, 2, 3, 4, 5, and 6 spots. When tossing a coin 3 times, the random variable C is the number of tails. This time we have the number of tails we get from tossing 3 coins. Then Z could be 0, 1, 2, or 3. So these are the values, the possible values of tails, the number of tails when we toss 3 coins. When we toss a coin 3 times, so it's either you will get, when you toss a coin 3 times, it's either you will get 0 tail, 1 tail, 2 tails, or 3 tails. So let's explore example number 1, non-defective laptops. So suppose 3 laptops are tested at random. You want to find out the number of non-defective laptops that would appear. Thus, to each outcome in the sample space, we shall assign a value. These are 0, 1, 2, and 3. So, example, from a set of laptops, from a group of laptops, you choose 3 laptops and test them at random. What do you want to test? You want to determine the number of non-defective laptops that appear. From the 3 laptops, how many are them? How many are non-defective? When we say non-defective, it is functioning well. Okay, so thus to each outcome in the sample space, we shall assign a value 0, 1, 2, and 3. Why 0, 1, 2, and 3? 0 if you do not find any non-defective laptop. So 0 if there is no non-defective. 1 if from 3 laptops there is 1 non-defective. 2 if from 3 laptops there are 2 non-defective. And 3 if all of the 3 laptops are non-defective. So what is our random variable here? What do you think is the random variable? Of course, we have the number of non-defective laptops. How to get the values of the non-defective laptops? So first, we have to create a table labeled as first column, you have the possible outcomes, and on the second column, you have there the values of our random variable. So to get the possible outcomes or to get the values, we have to use letter D for defective laptops. Defective laptops has issues or it's not in good condition, while non-defective, N, we will use letter N for non-defective, meaning it is functioning well, it is in good condition. So first, before anything else, we will list our sample space. We will determine the sample space. So what are the possible outcomes for our non-defective laptops for 3 laptops that's tested at random? So you have here, when you test 3 laptops, you may get either one of these possible outcomes. It's either, upon testing 3 laptops, you find out that the 3 laptops are defective. So that is the one possible outcome. The second possible outcome is 2 laptops are defective and the third one is not. Next, Next outcome, the first laptop is defective, the second is not defective, and the third one is defective. The fourth outcome, you may get the first laptop is non-defective, the second is defective, and the third is defective. Next, the next possible outcomes is the first laptop is defective, and while the two laptops are non-defective. Next outcome, the first laptop is non-defective, the second is defective, the third is non-defective. The other one, we have the first and the second laptops are non-defective while the third is defective. And the last possible outcome, we have three non-defective laptops. Now, we have how many possible outcomes? 1, 2, 3, 4, 5, 6, 7, 8. We only have 8 possible outcomes that would happen, that would appear if you test 3 laptops. And any of these, when you test 3 laptops, any of these outcome will happen. So you're not sure if what will occur, what type of laptops you will get from the 3 laptops, but you are taking chances that it would happen to appear as any one of these possible outcomes. So again, this is a random experiment, or this is in a random process. So what's next? We're going to place each outcome in our table. So possible outcomes. First, we have the the 3 laptops are all defective. It is a possible outcome. So you're not sure that this will occur, but it is possible that you will get 3 laptops which are defective. So how many? We will determine the value of the random variable. If our random variable is the number of non-defective, then what is the value of DDD? Of course, since there is no non-defective laptop, all are defectives, meaning, or before that, we have to list down first the possible outcomes. First, we have the DDN. Next is the DND. Next is a non-defective and 2 defectives. Next outcome, defective, non-defective. Next is non-defective, defective, and non-defective. Next, non-defective and defective. Next is the 3 laptops are non-defectives. Okay? Okay. So it is very important that you do how to list down the possible outcomes. You do it systematically para wala ka may ma-miss nga possible outcome. Okay? So, now we proceed to determining the value of the random variable. So, in our first possible outcome, the 3 defective laptops. So, what is the value of the number of non-defective laptops? May non-defective bala kita dira? Of course, there is no. So, if no non-defective laptops is to be found, then the value is 0 because we are concerned with the non-defective. Next, in possible outcome number 2, how many are non-defective? Of course, we have here 1. Next outcome, how many are non-defective? We still have 1. Next outcome, we have here 1 non-defective. In the next outcome, we have 2. 1, 2, 2 non-defectives. In the next outcome, we still have 2 non-defectives. And in the next outcome, 2 defectives, non-defectives in me. And in the last outcome, we have 3 non-defectives. So these are the values of the random variable for the non-defective laptops. Now, what do you think are the possible values for the non-defective laptops when tested at random? When three laptops are tested at random. So the possible values of a random variable are, of course, we have to summarize it. The possible values could be 0, 1, 2, and 3. So that's why the possible values for the number of non-defective laptops are 0, 1, 2, or 3. Why can't we see a value of 4? Why don't we have value of 4? Because 3 laptops are only tested, it is not possible to have a value of 4 because we only have 3 laptops tested at random. That is why the maximum value the maximum value of the number of non-defective laptops is only until 3. I hope it is clear with you. So answer these questions. How will you find the values of the random variable? How will you describe the previous problem? Is the variable discrete or continuous? So please answer that. Please write your answers in your paper. You can pause this video and write down your answers. I will check that. Okay, next example. Example number 2, tossing coins. So suppose 2 coins are tossed. Let x be the random variable representing the number of heads that occur. Find the values of the random variable x. So our random variable x is the number of heads. Sorry. So we have here the number of heads. So 2 coins are tossed. Our random variable is the number of heads that occur. What are the possible values for the random variable x? So it is already the number of heads, our random variable. Now how to get the possible values for our random variable or the number of heads? So we have to list down first the sample space. So what are the possible outcomes when you toss 2 coins? Anong pwede magwa kung ma-toss ka sa 2 ka coins? So when in the first activity or in the first experiment, it's either you will get 2 tails. When you toss 2 coins, either it would appear the possible outcome that would appear it's either 2 tails ang magwa. Of course, we're not sure that this is will occur, but this is only a possible outcome. We're not certain, we're not sure that this is actually what will occur, but this is just a possible outcome. Next, it's either, or we will use letter T for the tail, H again for the head. Another outcome is either you will get a tail and a head. The next outcome is either you will get 2 heads. And the next possible outcome is either you will get, on the first toss, you will get head, and on the second toss, you will get tail. So is there anything possible? Is there more possible outcomes aside from these outcomes that we have listed? I think there is no more possible outcomes. We only have 4 possible outcomes. So we have the sample space, TT, tail, 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 head, 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 and tail. So we only have 4 possible outcomes. So take note, these are just possible outcomes. We are not sure that upon tossing 2 coins, either head or tail will occur. So any of these 4 outcomes will occur. So you can try it. Try to toss 2 coins. I am sure the result would be any of these outcome. For our step 2, we're going to determine the values of the random variable or the number of heads. So the possible outcomes from our sample space is first tail, 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 head, 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 and head, tail. So what are we going to do? Just count how many heads are there in each outcome. So first, in our first outcome, how many heads are there? Of course, there is no head in the first outcome. That is why the value is 0. On the next outcome, how many heads are there? So it's only 1. We only have 1 head. On the third outcome, how many heads are there? Of course, it is clear we have 3 heads. And the next outcome, we have 1 head. Okay? So, what do you think are the possible values for our random variable, the number of heads? When you toss two coins, what are the possible values for the number of heads? So the possible values of the random variable x, so this is x. Random variable x are 0, 1, and 2. So we have 0, 1, and 2. What does it mean? So what does it mean when we have values of a random variable 0, 1, or 2? Meaning, when you toss two coins, it's either you will get 0 head, no head at all, meaning it's either you will get tail, tail, or you will get 1 head. It's either you will get tail, head, or head, tail, or 2 heads. It's either you will get head, head. So that is what the possible values mean. I hope that it's clear to you. To answer this question, how do you find the possible values of a random variable? So you just have to review this video lesson, or I guess you already know that. So you write down your answer. I will check that also. Now, let's proceed to activity proper. So again, in answering your last, do not write anything. Just have to provide a separate sheet of paper with proper label. For this lesson, you write it lesson 3. Read each problem carefully and answer it systematically. If solution is required, encircle or box your final answer. So activity proper. Exercise 1, drawing balls from a jar. Drawing balls from a jar, or just choosing a ball from a jar. Choosing balls from a jar. 2 balls are drawn in succession, sunod-sunod, without replacement. So if 1 ball is drawn, you do not put it again back. Okay? Without replacement. So from a jar containing 6 pink balls and 5 purple balls. So they are all pink. 6 are pink and 5 are purple. So we have 11 balls at all. So we use y as our random variable representing the number of pink balls. Find the values of the random variable y. Complete the table below. So what is our random variable here? The random variable is I know you already know that, the number of pink balls. So find the values of the random variable y, or the number of pink balls. Complete the table below. So example, we have here 6 pink balls and 5 purple balls. So list down. Again, just follow the steps on how to find the values of the random variable. So you just have to copy the table and answer these questions. So were you able to complete the table? If yes, how? If no, why? Were you able to find the values of a random variable? If yes, how? If no, why? So please answer these questions. If you have noticed, you have a clue here. We only have 4 possible outcomes. You only have to determine what are the possible outcomes by listing sample space and determine the value of each outcome in the sample space. Again, do not look in the answer key because it is cheating. So you have to answer it with yourself. I know you can do this. So what are the possible outcomes? Example, kung makuha ka sa 2 ka bola sa jar, what are the possible balls you will get? Okay, so we only have colors, pink and purple. So you can label, you can use P for pink, PI. You can use PI for pink and PU for purple. Or you can use any letter if you wish. Just label it. Okay? For activity 2, we have tossing 4 coins. This time we have to level up tossing coins. This time we have 4 coins. So 4 coins are tossed. Let t be the random variable representing the number of tails that occur. Find the values of the random variable t. So notice our random variable is the number of tails. So again, copy the table. You have a clue here of how many outcomes you will get. So you have there, I guess this is 16, 2, 4. I guess that is 16. So what are you going to find? List you are going to do. You have to identify your sample space. What are the possible outcomes? In identifying the sample space, just do it systematically for you to not miss any possible outcome. So para wala ka may malimtan or may miss nga um, outcome. So you can do it systematically. Okay? So just copy the table and follow the steps in finding the possible values. And of course, as it is already as an SOP, you have to write it down in your journal notebook, your reflection for this lesson. Lesson 3, you're going to write or answer questions from head, heart, bin, and bag. And of course, do not forget your comments, your suggestions, your feedback. Again, your journal notebook will remain, or your journal notebook is part of your performance task. Also, please submit or write your feedbacks or comments for this video lesson for improvement and, of course, for the improvement of this video lesson. Thank you for listening. Next, we will have another lesson.